Welcome to my channel in our world. Hey guys, once again welcome to my channel. Today I will teach you how to solve shear force diagram. Now I will come to a question. Calculate the shear force for beam subjected to the loads as shown in figure. Draw the shear force diagram. Here is a diagram displayed in your screen. In this diagram, this is a fixed and this is a roller. When there is a roller, there will be only one vertical force. But in case of fixed, we'll have both vertical as well as a horizontal force. This is an UDL, uniformly distributed load, till the point C, and this is a point load acting here at the point D, vertical load. Let's go for the solution. Here I have resolved the forces here with the distance. Consider this point RA is a vertical, the horizontal RAX. Here at the point V, this a roller was there, so I have resolved the force, that is RBY. Now what I'm gonna do is, first I'm gonna find the moment at point A. So here I found the moments. Well, starting from here, this is UDL. How I have said how to find the UDL, that is, this is a small w into total length into L by 2. So 10 into 4 into 4 by 2. 4 by 2 comes 2. Now how to find the moment? The clockwise direction is a positive and anti-clockwise direction will be negative. So this plus another one, what we have here, 20 kilonewton. So 20, all are in same convention, so no need to change that, keep it as kilonewton. This is also clockwise direction. So 20 into, what is that, 4 plus 4, 8 plus 2, 10. So 20 into 10 in clockwise direction. Now comes RBY. RBY is acting in an anti-clockwise direction. So minus RBY into, what is a perpendicular distance, 8, equals 0. So from here, if you simplify this, you get as RBY. Now what you do is, now you do summation of all the vertical forces. So what are all the vertical forces? RAY plus RBY, RAY plus RBY minus 20, and here also minus 10 into 40, 10 into 4, 10 into 4. So you get this here, and you know already, you know the value of RBY, and you substitute here, you get as RAY. You get this one. Now summation of horizontal force. We don't have any horizontal force, so RAX will be 0. So here we complete all the reaction forces. Now I will show you how to find the shear force diagram. So here is the now here this is now what we know, RUN, run, right upper negative. This is what we have. We have a right downwards, right side downwards gives a positive. So what will be there? So I will increase the same amount, 20 upwards till the 20. Now in between the D and B we don't have any loading. In between the D and B we don't have any loading. So it will be coming constantly till the point B. See, in the B point what we have a load acting vertically upwards. A load acting vertically upwards. So upward, what we know, U upward is a run. Upward means negative. So we can write, that is 20, what is the existing value, take that value here, then negative of negative 35, what we get, minus 15. So The minus means what? From the baseline it will go downwards direction till the magnitude 15. Now in between the B to C, we don't have any magnitude. So we will keep a horizontal line till the point C. Now from the C and A, we have a uniformly distributed load. Now again we need to calculate the value. How you are going to calculate? Previous value. Take the previous value minus 15 and calculate this. How you got 40? 10 into, what is the distance? Distance is 4. Here the distance is 4. So 10 into 4 you get as plus 40, because these are the acting downwards. Downwards means positive. So what you do is, so you calculate that, you get as 25. Now 25 is a positive value. 25 is a positive value. So from the 15, what you do is you gradually increase to the point 25. Gradually increase to 25. Now again, what you do at the point A, we have another load acting vertically upwards. Upward means negative. So we have already previously we have 25, now minus 25, it gets 0. So this, from this line it will come to 0 and touch the baseline. Make sure whatever the shear force you draw, the free ends will be 0. I didn't want to make a long video. If you still have any inquiry, please drop onto my mail or in comment box. Share this video with your friends, senior or junior. Goodbye. Take care.